All right, let's go over this Unit 4 warm-up, and it also has a little bit of Unit 3 normal model stuff in it. So here we go. Okay, here, the key here was that you needed to be able to recognize what component was X and Y, that we were given these summary statistics, okay, and then work your way through writing the equation of that line. So here we go. I first acknowledged that X was the age of the mother as the explanatory, Y was the birth weight of the baby. So then you will have this equation on the board that the slope equals R times the S of Y over S of X. Okay, so that will be on the board because that is on your AP formula chart. So that's given to you. So I plugged in those numbers from up here. Got a slope of 244.24. Now, this one won't be on the board. This is something that you need to know. You know that your y bar equals m times x bar plus that y-intercept. So see, then I'm going to fill in 3 of the 4 things that I know. Plugging in that y bar here equals the slope that I just found right here times x bar, which is 17, plus that y-intercept. So I solved for the y-intercept and determined that it was negative 1147.98. So in context, write your equation with the predicted birth weight. So if I was typing that in for my online people, if I was typing that in, I'd put predicted birth weight equals those things, 244.24 times age in years minus the 1147.98. Now, then it also asks you to predict the birth weight of a baby born to an 18-year-old mother. So that's when you plug in 18 and you get that predicted weight in grams. All right, this next one was a throwback to Unit 3 with normal model. So I just come over here and I start listing my information I have. Mean, standard deviation, the x value is 3. So I'm going to get my z-score, x minus the mean over the standard deviation. And I got my norm. So once I have that, then here I have this going on here. This is where my z-score is at negative 1.33. And I want that percent of area, the probability, remember probability, percent, proportions of observations, use norm CDF to get that area. So about a 9.18% chance the randomly selected student has lower than 3.0. Here, in order to qualify to be in the Honor Society, you have that top 5%. So if you have a calculator that will get the z-score at this spot by doing the 5% to the right. Otherwise, you are doing inverse norm of that area below is the z at that spot. So that's how I get that this z-score here is inverse norm of 0.95. 1.64. Then I come and set up this equation here to then solve for x. So that's 3.89. Next, here, one of the things is that I first asked you to do is identify, again, that's an important thing off the bat with this bivariate data. Identify what your x variable is and identify what your y variable is. So I did that here. Now, next, we have this situation where we are describing the relationship. In other words, interpret the correlation. Well, that's right, this. That's there, R equals 0.685. So there is a moderate, positive, linear relationship between verbal SAT score and math SAT score. Now, as you can see here, this is like problem number 1, where you are then to recognize that I'm giving you the mean of the x and y and the standard deviation of the x and y, which you will use with that correlation right there and solve just like you did problem number 1. I'm not going to go through that detailed, but this is the equation you get that you can predict your math SAT score by doing 0.66 times your verbal SAT plus 218.64. So then I asked you to interpret the slope of that line, which is that 0.66. So that's kind of strange. Literally, it's for every 1 point increase in the verbal SAT, the math SAT score is predicted to increase 0.66 points. But you kind of got to keep common sense and worldly stuff in mind. SATs don't really go up by those 1 points. They'll go up by tens or even 100s. So go up by one of those is probably more likely the way that you would see the problem written in the interpretation of the slope. So you could say for every 10-point increase in the verbal SAT score, the math SAT score is predicted to increase 6.6 points. Probably more likely to show up as an answer choice than the other, which isn't a realistic situation. Coefficient of determination about Okay, so I took the R from problem C and then I squared it. So about 47% of the variation in the Y can be explained by the changes in the X with the context in there. And so here then predict a math score with that verbal score of 500. So I just put that verbal score of 500 into the equation I had computed earlier and got my answer. But H was something that you had to think about because H said this student gets a perfect score of 1600. Here's the thing that you had to know, or you had to figure out with your brain and context worldly, understanding of things. 1600 means that the X score is 800 and the Y score was 800. So that tells you the verbal score was 800 and that the actual Y was 800. So you can then, from that, figure out what the predicted Y is by plugging the X of 800 into the prediction equation. So that means a student who gets 800 on verbal is predicted to get 746.64 on the math. But that person actually got 800 on the math. So residual is the actual Y minus predicted Y. Residual rep actual minus predicted. So that residual is 53.36. All right. True story here. Interesting information going on here, kind of a tale that I did get a 490 on my language part, my reading or whatever that is. Just have to tell you a little secret. I've never read a book. Well, actually, that's a lie. I read How to Eat Fried Worms in 4th grade, okay? And then I did a book report on it, a repeat of that book in 5th grade. So back in my day and the school I went to, I was able to just kind of get by without that. So very interesting. I had a 490 on my verbal. Now, math came naturally, so even though I might not have had school support on that, it was just kind of in my brain. So I had a residual of 220. So our X was 490. You don't know what I made actually on my math, but we can predict with a 490 verbal, I was predicted to get 542 on my math, but I had a residual of 220. Actually, it was a little different, but anyway. So there's my 762.04. Of course, that wasn't realistic. So truly, my residual, I should have said, was 217.96. Okay, but anyway, you get the idea of what's going on there. Next. Okay, so here, if you weren't sure what is X and what is Y, then you look right here. That's your X variable. So the student enrollment was X. Keep in mind that this is in thousands, okay, number of students in thousands. So there's that. Therefore, you have to know your coefficients right here. The number of teachers in thousands is 0.053 times the students in thousands plus 4.486. There's your coefficients. Okay, next, then interpret the slope. For every additional 1,000 students, there's predicted to be 53 additional teachers. Next, interpret the correlation coefficient. That's the square root of this 0.815, not square root 81.5. 0.9. There's a strong positive linear relationship between that, so on and so forth. Coefficient of termination, 81.5. I already said the percent of variation in the y that can be explained by the changes in the x, and putting those in context. Make sure you know these because we haven't assessed these sayings. So our standard deviation of the slope is first. That standard deviation of the slope is right here in red on that slope line, okay? So that's saying that if you sample many times, I'd expect the slope you find to vary about that much on average. If you sample many times, I'd expect the slope of the relation between number of students and number of teachers to vary about. Now, what I did here was I multiplied. Technically, you could say 0.001692. Okay, but I tried to make it realistic. I wouldn't mark off for that for you. 1.69 teachers per 1,000 students on average. Okay, because I just multiplied that standard deviation times 1,000. So as per 1,000 students, you're going to get about 1.69 different amounts of teachers per student. Okay, standard deviation of the slope, right? Or the residuals, standard deviation of the residuals right there. Okay, so that's the average amount that the actual y value point varies from what's predicted to become. So varies from the predicted y. Average amount that the actual number of teachers varies from the predicted number of teachers is 2.589 teachers. All right, so there is that. I think well, and we'll go ahead and go over this. You can see this point here, not high leverage. It's basically no leverage. It's smack dab in the middle. It would not influence that line. It is an outlier because it's high up there. Now, it is making correlation go down, so removing it will increase that correlation, and it is not affecting the slope. This next one, super important. Super important. So let's pay attention to this one. Okay? Now, this is so interesting. Shoe size, IQ, context. What's this problem about? Your shoe size and your IQ. Do you think your shoe size has an effect on your IQ? Well, according to this data here, no correlation. See that dotted blue line? No correlation, no linear correlation. It's a miss. No, doesn't matter. Your shoe size not having an impact on your IQ. All right, but what if we had Bozo the Clown, who is a freaking genius? He's got a high shoe size and a high IQ. And look at how impactful that point is. It is so impactful that it makes it look like there is a relationship between your shoe size and IQ when there really is not. That's a big deal. Okay, that's interesting. We haven't seen that one yet. So, high leverage, absolutely. Influential, absolutely. And definitely an outlier. So, look here. This one, the interesting thing here is that this point is actually increasing the correlation. If I had been able to show you the computer simulations and show that around to you, I would show you how that makes it seem as though there is a correlation when there really is not. So that point strengthening it. Therefore, removing it would decrease that correlation. Interesting. Okay, and then of course that point made that slope increase. So taking that point out would make that slope decrease back to basically nothing. No correlation and no zero slope. Okay? And this, hopefully you got to go over this or think about it or look at it. I did kind of have that situation down here for you to look at. So this is a good test review, even if you haven't gotten to look at it before this quiz. All right, and then I think I'm going to hold off on this free response. You could look at it on the answer key if you wanted to. This second page is really very, very interesting. Maybe I'll get to go over that while you're working on your review tomorrow. All right. Good luck on your quiz. It's quite lengthy, so bide your time quickly and to work yourself through it. Good luck.